Hi, I'm Wendy Zukerman, and you're listening to Science Versus from Gimlet. This is the show that pits facts against fireballs. On today's show, asteroids. In just 2 weeks, NASA is expected to launch a first-of-a-kind mission. Its goal? To move an asteroid. So that if a space rock is hurtling towards Earth, then you and I will be safe. This mission is totally bonkers, and we at Science Versus are super excited about it. So we gussied up an episode that we dropped just a few years ago about how an asteroid really could muck things up for Earth and what this new NASA mission is all about. So, let's jump in. We're going to start our story on February 14th in 2013. The world's finest asteroid researchers were meeting for a conference in Vienna. Alan Harris was catching up with some colleagues.
We had a nice evening in a restaurant in Vienna. You know, talking shop, as people do.
Some of that shop talk was about an asteroid that was expected to fly by Earth the next day. It had been discovered a year before, and scientists had been tracking it very closely. They predicted that it was going to just skim past us.
It was coming quite close to the Earth. The scientific community was ready and waiting. And so we were all geared up. We were expecting it.
The asteroid is called Duende. It's a potato-shaped rock about 130 feet across. And it was expected to be one of the closest encounters ever recorded between us and an asteroid of its size. Scientists had press releases ready and interviews scheduled. It was all rather exciting. So, with a big day ahead, Alan hit the hay.
You know, brushed my teeth, had a wash, and then just fell asleep.
In Vienna, Alan slept peacefully. But 2,000 miles away, in the city of Chelyabinsk in Russia, Sergey Zamozdra, an astrophysicist, remembers hearing the asteroid as it exploded over his hometown. Sergey says some people were frightened. He also told us that when the asteroid exploded, it caused a chemical reaction. He says the air smelt different. Some people even sensed a different taste in the mouth. They said it had some metal flavour. Across the city, the blast damaged buildings, caving in some roofs and shattering windows. More than 1,000 people were treated for injuries, mostly cuts from broken glass. The asteroid ended up causing millions of dollars in damage. But back in Vienna, Alan had no idea what had happened while he was sleeping. He woke up, brushed his teeth, and headed down to breakfast.
All I could see from where I was sitting having my breakfast was a reflection of a TV monitor, which was just showing the news. And the picture that kept being repeated was that of a streak across the sky. But then I managed to read I think it was the word meteor or something, backwards.
Alan was confused. Duende, the asteroid scientists had been tracking, wasn't supposed to come by Earth until later that night. And it wasn't meant to hit Earth, just come close. He realised that this asteroid that had just exploded over Russia, it wasn't Duende. It was an entirely different asteroid.
And that's really when my jaw dropped. My jaw just dropped. And I got up, I left my breakfast on the table, got up to actually view the TV screen directly. I gaped at the screen, I think, when I saw this. I just couldn't believe it. This was just total coincidence.
Alan just stood there agape for a bit, processing what he'd seen. He was totally stunned. But of course, he had a meeting to get to, so he hopped on the metro.
We got onto the train, and there immediately, just sitting right in front of us there, were the colleagues from the Jet Propulsion Laboratory and from NASA headquarters. So, you know, all the people in the world you would want to talk to about this event were right there.
Did any of them have any idea that this might happen?
Not at all. Nobody could have predicted this. We didn't know anything about it, you know. The only event that was predicted was that of the close approach of Duende.
Alan says some researchers were a little red-faced.
Well, I think there was a little bit of embarrassment. You know, how are we going to explain to the world that we did not see this coming?
Yeah, I mean, really, how are you going to explain it, Alan? How did you and the rest of the asteroid researchers spot one asteroid that was passing by Earth, but miss the one that slammed into us? That answer, today on the show. Plus, if we did spot an even bigger, supersized asteroid heading straight for us, is there anything we could do to stop it? When it comes to asteroids, there's lots of... But then there's science. Science versus Asteroids is coming up just after the break. Welcome back. Just a few years ago, as scientists around the world were carefully tracking the movement of one asteroid, Duende, another one, Chelyabinsk, smacked us in the face. So how did this happen? How did we have all this information on one asteroid and nothing on the other? Well, to answer that question, we're first going to tell you how we knew that Duende was going to sail past us. About a year before the big NASA whoopsie, some nerds were looking up at the skies using a big telescope off the south of Spain. And that's when they saw this tiny dot moving.
They got a couple of images and saw something that moved differently relative to everything else. And were able to say, oh, hey, we think we just found an asteroid.
That's Cathy Plesko. She studies how to save us from asteroids at the Los Alamos National Laboratory in New Mexico. And Cathy told us that, as is protocol, the nerds in Spain reported their finding to the Minor Planet Center. They keep track of every asteroid that's ever been discovered. And so they looked at their records and asked,
is this something that's been seen before? And everybody went through and checked and said, nope.
This was a new asteroid, and it looked a bit like it might be headed for Earth. So the Minor Planet Center put out a call to a network of telescopes around the world, saying,
everybody else, hey, go look for it because this looks like it might be something coming at us, so let's go get more images and establish its orbit.
So scientists from all around the world pointed their telescopes at Duende, trying to get a picture of it to see how it was moving. A telescope in Spain spotted it at 1:45 a.m. their time. In France, they caught it at 3:21 a.m. Arizona spotted it at 5:30 a.m. And each time someone saw it, they took a picture and sent the coordinates to the Minor Planet Center, who verified it and put it on an official map.
That's when we know whether or not it's going to hit us, is once we learn enough about its orbit.
When scientists crunched the numbers to pinpoint its orbit, they realized that Duende would miss us, but come close. Remarkably close, as NASA put it. The nerds breathed a sigh of relief, and scientists' predictions about when and where Duende would be were totally on the money. It sailed past Earth just as they thought it would. But any pats on the back were overshadowed by Chelyabinsk. And Cathy says that just like Alan and all the other researchers in this space, she was completely shocked.
What just happened? I literally did the take a sip of coffee and then did a little bit of a spit take on my monitor.
So how did we know about Duende but miss Chelyabinsk? Well, what made Duende special is that it was easier to see than the average space rock. You see, asteroid hunting tends to be very tricky, partly because most asteroids are dark, really dark. And in the darkness of space, that's a problem.
These things are really hard to find. They're all fairly dark, so asteroids tend to be about as dark as black velvet or like charcoal briquettes. So if you're looking for charcoal briquettes in space, that's a lot like looking for black cats in a coal mine.
Duende, on the other hand, was bright for an asteroid. More like spotting a grey cat in a coal mine. And Duende had another thing going for it. The direction it was coming from. You see, one of the problems with Chelyabinsk was that in the weeks leading up to it hitting Earth, it was basically coming from the direction of the sun.
So we weren't going to be pointing a lot of telescopes at it because if you point a telescope at the sun that's not prepared to look at the sun, you start a fire on your mirror.
Yeah, if you've ever tried to burn an ant with a magnifying glass, you know why. Just imagine that on a very big scale. Also, shame on you. Didn't you listen to our episode on ants? Okay, so a couple of things came together that made Duende easier to spot. It was bright and not coming from the direction of the sun. But it's still kind of a miracle that we found it at all. Because here's the thing. Duende was small. It was only about 40 metres across, some 130 feet. And in the vastness of space...
That's tiny. That's really hard to find.
Chelyabinsk was also small, about 20 metres across. So Cathy is not at all surprised that we missed it.
So there are a lot of 20-meter objects out there that we don't know about.
Oh, wow. So we are still missing some potentially dangerous asteroids.
So many. Oh, so many of them. Yeah.
So that's the story of Duende and Chelyabinsk. But those are just two pretty small rocks. Asteroids come in all different sizes. And the larger they get, the more dangerous they are. When asteroids get up to around 1 kilometre, things get very, very, very scary. That's more than 100,000 times bigger than our friends Duende and Chelyabinsk. It's roughly the difference between a basketball and a hot air balloon. And if one of these space rocks hit Earth, it would be so much worse than Chelyabinsk.
It would hit, and then boom, if you were there, say it hit Manhattan, you wouldn't survive. So you'd be vaporized.
What do you mean vaporized?
What happens is this chunk of rock hits and it's still going really, really fast. It's squishing up. And so it's slamming in, Earth is pushing back. It compresses until finally it runs out of gas. And then you've got this super dense, super hot piece of rock that then decides, oh, it needs to be a vapor. It's got so much energy in it that it just explodes.
The power that this rock would hit the ground with would basically turn anything near it to dust. These asteroids would hit with a force that is thousands of times more powerful than the nuclear bomb that detonated over Hiroshima.
There's a reason we're using, nuclear terminology to describe this, because it's just that huge.
It is crazy to think about.
It really is.
And the effects would be felt throughout the entire world.
Right. So something where if it hit the Earth, it would wreck the Earth's climate and prevent crops from growing for a year or two.
When a large enough asteroid punches into Earth, it can throw up so much dust into the atmosphere that it literally blots out the sun. Scientists think this dust helped doom the dinosaurs when they were struck by this super giganto asteroid. So long, dinosaurs. So, could this happen to us? Well, the good news is that the bigger an asteroid is, the easier it is to spot. So, we'd most likely see one of them coming. We'd have time to run around screaming. No, we'd actually have time to do something about it. But what? That's coming up after the break. Welcome back. Today's show is all about asteroids. So, if a big scary asteroid was racing towards us, how could we save ourselves? Well, luckily, people at NASA have been asking this very question. And they've got some plans of attack, which are different depending on how big the asteroid is. We're going to start with the plan for a medium-sized asteroid. So, if Chelyabinsk was a basketball, these are like the height of Steph Curry. And they're big enough to do some real damage, like wipe out a large city and its surrounding areas. And here's the thing. In just 2 weeks, NASA is going to launch a spacecraft to deal with this kind of rock. The mission is called DART, and it's a world first. Andy Cheng is one of the lead scientists on the mission. It was his idea.
It just came to me. Once I thought of it, I said, oh, wow, this is really what we got to do.
Okay, so here's the plan. A spacecraft is going to whack into an asteroid to push it out of the way. Literally. That's the plan.
If you have a threatening asteroid that's going to hit the Earth, you want to change its orbit by enough so that it won't hit the Earth.
And while this whole whack an asteroid idea seems like something your 3-year-old might have come up with, there's actually some huge technological feats involved. Hitting the asteroid will be extremely difficult because both the asteroid and our spacecraft are moving fast. The spacecraft, for example, will be zooming towards the asteroid at 9 times the speed of a moving bullet.
This is by far the smallest target that we have ever tried to hit with a spacecraft, and we're hitting it with a spacecraft going 13,000 miles per hour. It's very much like hitting a bullet with another bullet. NASA has never launched a mission like this before.
The asteroid we're gunning for is called Didymus B. It's nicknamed Diddy Moon. It's about 160 meters across, which is like 6 blue whales, long ways. And Andy and his team picked it because it has a friend nearby.
It's an 800-meter guy. He's spinning very fast.
You see, Diddy Moon is orbiting a space rock 5 times its size. And this was Andy's big idea, to target a pair of asteroids. And that's because the way that Diddy Moon kind of dances around its mate, it'll make it easier to detect how much Diddy Moon will be shoved when the spacecraft hits it. Easier than, say, if we just hit a lonesome asteroid. And to do this mission, we're sending our best and brightest.
The spacecraft is a refrigerator-sized box. Now, it has big solar panels. When they're fully extended, are almost 19 meters from end to end. That's like, what, more than 60 feet?
Does it look a bit like a bird's wings?
Yeah, well, it's a strange-looking bird.
The solar wings will power the spaceship's engines and processing. And so, after more than a decade of waiting, several months ago, Andy saw his little refrigerator bird all put together for the very first time. Was it like seeing a grandchild when you walked in and saw it?
Oh, yeah. It's a baby. Yes, it's our baby. Yeah, it is somewhat like watching your kid doing a recital.
In just 2 weeks, on November 24th at around 1 a.m. Eastern Standard Time, Andy will see his baby sing. It'll be launch time. He'll be watching on big screens at a NASA lab in Maryland.
I'm going to be clenching my hands together so I don't fidget. And it's very tense, believe me. Very stressful.
What's the worst thing that could happen?
Spacecraft doesn't launch, blows up. Rocket blows up.
Right.
I feel it has to work, but there's all kinds of things that have to happen to go right, you know? They have to go right, in the right order, in order for all this to work. So I'm nervous about that. On the other hand, I'm also very excited. Gosh, all these, it's finally going to happen.
And if all goes to plan, here's what'll happen. It'll take about a year of flying until the spaceship will get its very first glimpse of the asteroid. From ground control, Andy will see a tiny dot on the spacecraft's camera get bigger and bigger and bigger. Andy and his team will help guide the spaceship to its target. But as it gets close to the asteroid, our spaceship will become autonomous. So that means our little space chicken will have to find Diddy Moon all on its own and smash into it.
That's the nail-biting part. That's when it gets really tense, because the spacecraft is on its own, and this has to work or, it's not going to hit. We're, of course, watching from the ground. Very tense.
If all goes well, this will be a kamikaze mission. And Andy says he'll be very well aware of this as the end comes close. He'll be counting down.
The end of its existence is 4 minutes away.
As the ship gets closer and closer.
20 seconds before the end. Target getting bigger and bigger and bigger as you get closer and closer. 5 seconds.
From ground control, Andy will be seeing Diddy Moon almost fill the entire field of view. Our little flying fridge will greet the giant space rock. And then...
Silence is what it is. Silence, darkness.
You wouldn't hear a thing. Sound can't travel in space because there are no air molecules for it to vibrate through. But come on, that's no good for a podcast. Cue the sound effects. That's more like it.
Spacecraft is destroyed. It'd be pulverized.
Bye-bye, birdie. And what will become of Diddy Moon?
So the asteroid will sort of dust itself off and, keep doing its thing. Its orbit will have changed.
Telescopes from all around the world will have been fixed on this crash so that they could measure the change in Diddy Moon's orbit. And if all this works out and we can hit and move Diddy Moon, which isn't a threat, that means we could use this same technique on something that is actually on track to hit Earth. Okay, so this is the plan for a medium-sized asteroid, the kind that could wipe a city out. But it couldn't work for something bigger, say an asteroid that could threaten the entire world. They're just too big. It could swat away our refrigerator bird like a fly. So is there anything we could do to save ourselves from one of these monsters? Well, Cathy Plesko says we've got a plan for this.
So probably that would be a nuclear issue.
A nuclear issue. As in, bring out the nukes. Cathy says that blowing up the asteroid with a nuclear device, while not totally off the table, isn't ideal because it would just break the asteroid up into lots of little asteroids, which could then come hurtling down to Earth and cause trouble. I guess that 90s documentary Armageddon got it a bit wrong. Still, Cathy reckons that we could use nukes, just a little differently.
So the idea there isn't to necessarily shatter it and blow it up. The idea is to push on it.
Push on an asteroid? With a nuke? Here's how it would work. We would explode a nuclear bomb near an asteroid, so the explosion itself would push the asteroid out of the way. And basically, what we're trying to do is to make the surface of the asteroid become so hot from the explosion that it'll start to vaporize. Because that vapor,
it wants to expand really, really fast and really, really hard. And so that vapor expands off the surface, and as it's moving away, it's pushing a little bit on the surface of the asteroid that's solid. And I know this is a hardcore science podcast, so I'm going to get a little mathy. A lot of people will have seen the ideal gas law, PV equals nRT. And oh no, too nerdy, back up.
Hardcore science. What kind of show do you think we're running here?
Oh dear. Okay, I'm sorry I just nerded all over your podcast. So let me back up. All right.
Yeah, let's back up. The ideal gas law basically tells us that the nuclear bomb would heat up the surface of the asteroid so much that it'd start to vaporize and create a ton of pressure that could ultimately push the asteroid off its course. And it's not just about nudging the asteroid a little to the left so it would miss us. Both Andy's refrigerator bird and the nuke near it option would also change the speed that the asteroid is moving, which means it might slip past us.
The asteroid is delayed a little bit or hustled up a little bit so that when it does cross Earth's orbit, Earth is not at that point in its orbit. So it would, instead of hitting the Earth, it would be like doing a zipper merge on the highway. It would wait its turn and then pass through, and nobody gets hit.
Through computer simulations, Cathy has found that if you did have a massive asteroid hurtling towards Earth, and you did her nuke near it trick, it should work, as long as we have plenty of time.
1 centimeter per second change in velocity, 10 years ahead of time, would make the object miss the Earth by 1 Earth diameter.
Wow.
Which is really close.
Basically a bee's dick away.
Yes. That's a skin of the teeth miss. This is a very slow, very big ballet. This is not something you can do really fast. This isn't Star Trek where we're going to fly out there with our photon torpedoes and just shove it out of the way. And then in half an hour, everybody's having cake and fireworks.
So now that we know what we do about big asteroids heading towards Earth, what's the chance that we're actually going to need any of these plans? Like, how likely is it that an asteroid would be heading our way? Well, to figure this out, scientists count how many asteroids we're tracking in a given part of space, and they calculate the likelihood that we've missed some. They feed that information into statistical models. And according to these models, they expect that a Chelyabinsk-sized asteroid would hit us, on average, every 100 years or so. One in every 100 years. The city killers, the Diddy Moons, they hit way less often. One in every 20,000 years or so. And as for the really, really big rocks, the ones that could change the world's climate, well, looking through our telescopes, we don't see many of those in the skies. So to get more information, scientists count craters. Literally, they count the scars where asteroids have hit in the past.
So we know from the moon, we know from the Earth and the other planets that we've looked at what the impact record is. So we do have a pretty good handle about how often objects of different sizes hit.
And from this, scientists have found that these really, really big asteroids,
those objects that size hit maybe every 100,000 to 500,000 years. Casino odds. And so they do happen, but it would be like winning the worst lottery ever if it happened to us tomorrow.
And then so why do you study this option that will only be used for the big ones?
It is a very low probability thing, but I also don't expect to have a kitchen fire, but I have a fire extinguisher in my kitchen. Ideally, like the best possible outcome for this work that I am spending years of my life on, honestly, is that it will become a dusty little PDF file on somebody's computer and we won't ever need it. But in case we do, it's better to think through it when no one's shouting about it, when nothing is aimed at us. So let's do the models now.
And Cathy reckons that the ideas that scientists are cooking up here, like nuking near it and whacking into it, they will work. Which makes asteroids kind of special when you compare them to other natural disasters.
We know how to do this. We can't right now deflect a hurricane and tell it to go somewhere else. We can't cork a volcano. We can't superglue the San Andreas Fault shut and stop it from making more earthquakes. We can potentially push an asteroid off course and stop it from hitting the Earth with technology that we have right now.
So, when it comes to the asteroid apocalypse, should you be worried? Well, probably not. We've got some good ideas to get one out of the way if it really was coming for us. Plus, the odds of a big scary asteroid hitting us in our lifetime, it's just so small. I mean, it's just really, really, really... That's Science versus Asteroids. Hi, Lexi Krupp.
Hi, Wendy Zukerman, the executive producer.
That's true. It's a true story. How many citations in this week's episode?
Oh, this week we have a healthy 119 citations.
119. And if people want to get these citations and see them and learn more, where should they go?
It's linked in our show notes or head to the website at scienceversus.show.
What was your favorite fact that didn't get in the show?
Oh, my fun fact is that the Chelyabinsk asteroid was so powerful that it gave people a sunburn.
That is crazy. And what is also kind of crazy is the fact that we have our sound engineer here.
Wendy.
Peter Leonard.
Hello.
How many different explosion sound effects are in this episode?
There are 16 different explosions in this episode.
Really? But you mean over the top of each other, right?
Yes. Yeah, many of those at different times were layered on top of each other for the times in the episode where we needed big explosions.
And we needed it. Yes. Thanks so much, Peter. Thanks so much, Lexi.
Thanks, Wendy.
This This episode was produced by me, Wendy Zukerman, along with Lexi Krupp, with help from Michelle Dang, Meryl Horn, and Rose Rimler. We're edited by Caitlin Kenney and Blythe Terrell. Fact-checking by Michelle Harris and Ekedi Fausther-Keeys. Mix and sound design by Peter Leonard and Bumi Hidaka. Music written by Peter Leonard, Bobby Lord, Bumi Hidaka, and Emma Munger. Recording assistance from Verónica Zaragovia, Sofi LaLonde, Lawrence Lanahan, and Kevin Caners. Translation help from Andrew Urodov and Dmitriy. A big thanks to all the scientists we spoke to for this episode, including Dr. Carrie Nugent, Dr. Mark Boslow, Dr. David Kiring, Dr. Daniel Durda, Dr. Kelly Fast, and the other Dr. Alan Harris. Also, a big thanks to the Zukerman family and Joseph Lavelle Wilson. I'm Wendy Zukerman. Back to you next time.